Okay, let's go and talk about the characteristics of a acid. So let's first talk about the solution. So when we have an acid and we put the acid in water or in an aqueous solution, you might hear in a chemistry class, what ends up happening is that acid, it breaks off to one or multiple H plus ions. It gets separated with the anion, which is the other counterpart that was combined with the hydrogen ion to form its covalent compound. If this is a little bit confusing, I have two examples here to show you. The first example is we have HNO3. Now if we put this HNO3 inside of water, what ends up happening is this H right here breaks off into the H plus ion. The other part, NO3, has a negatively charged. It goes in and breaks off on its own. So inside of the solution, now we have a H plus ion and an anion, which in this case is polyatomic ion, NO3 minus. This minus is a -1 charge. Okay, example 2. Can you work it out? It's a little bit more confusing, but what happens over here is actually, because the subscript tells us that we have 3 hydrogens, this, in aqueous water solution, breaks off, and this tells us that we have 3 hydrogen ions. So right over here, the 3 hydrogen ions break off. PO4 is another polyatomic ion, and because hydrogen carries a +1 charge, 3 of them will give us a +3 charge. With a +3 charge, that means our PO4, our polyatomic ion, has to have a 3- charge. And this, because the 3 H plus ions break off and dissociate in water, we're left with this anion, which is right here. So as you can see in these two chemical equations, we can go and see the covalent compound, and after it gets mixed in an aqueous solution, it dissociates, releasing the H plus ions. Okay, number 2, let's talk about taste. Acids, they taste sour. You probably don't want to be tasting strong acids on its own, but if acids mixed in with food, they can be quite tasty. Now, right here, we have a picture of a lemon. Lemons are sour, so whenever you guys are ever thinking about how acids taste, we go ahead and think of a lemon or vinegar. Okay, what gives acid their sour taste is both hydrogen ions and hydronium ions. Now, a common mistake is a lot of people think hydronium ions and hydrogen ions are the same thing, but they're actually not. Hydrogen ions break off covalent compounds, as we can see right over here. So, assuming that we have some sort of acid, it breaks apart a whole bunch of hydrogen ions, just like that. Now, because the hydrogen ion was dissociated in water, it immediately attaches itself to a water molecule. And water molecules are H2O. So when we have H2O and H plus in the water, one of the H plus quickly attaches itself onto the H2O. Attaching itself onto the H2O will go ahead and give us H3O. Now, why do we have a charge right there? The reason why we have a charge is because this H came in with a positive charge, and originally, the water, H2O, was perfectly balanced. Because of this positive charge, we're going to go ahead and add a positive charge onto the H3O, which is the new water molecule that had the hydrogen ion attached itself onto it. So this, right over here, is what happens when H plus ions get dissociated into the water. As well as this is the exact reason why acids taste sour. Okay, next let's go and talk about reactivity. When we have an acid and we put a metal inside of the acid, that's going to go ahead and give us H2 gas. Now let's go and use an example, because this on its own might be a little bit confusing for some of you guys. So right over here, we have our acid, 2HCl, and then we have our zinc, Zn right over here. Once we combine the two and we put the metal inside of the acid, the H2 gas breaks off. Hydrogen gas usually starts getting released in bubbles. The zinc then goes ahead and joins with the chloride, which is what we have right over here. If you're wondering why Cl has a 2 right over here, this comes from balancing equations. We have 2 chlorine right over here, and right over here, before we add the 2, we only had 1 chlorine. Adding the 2 will go ahead and give us 2 chlorine, which means that our equation will be perfectly balanced. We have 2 hydrogens, 2 chlorines, and 1 zinc. If you guys haven't done an experiment of what this looks like, let me just do a quick drawing for you guys. Say you guys have an acid right over here, and it's filled around this mark. When we go ahead and drop a coin or a piece of metal right there, what ends up happening is this H2 gas, the hydrogen gas, starts getting released as bubbles. And lots of bubbles will start forming around the metal. And if you don't have an enclosed container, that H2 gas will start to get released into the air. And over time, this piece of metal, if you wait long enough, will end up dissolving and completely be gone. Okay, now let's go ahead and add our piece of metal back. The rate of the metal dissolving completely and the amount of bubbles that will be formed is determined by the strength of the acid. The stronger the acid, the quicker a piece of metal will start to dissolve, and the more bubbles will form. Other than the strength of the acid, the type of metal, the amount of surface area, the concentration, as well as the amount of the metal will also contribute to how quickly the metal gets dissolved and how much bubbles will be produced. Just remember, stronger acid, stronger concentration, more surface area, more metal, and the correct type of metal will cause more bubbles to form and more of this H2 gas to be released into the air. Now, what do we mean by surface area? In the same solution, if we have 2 containers, one container right over here, and one container right over here. These are both filled with acid. if in one container we add powder metal, this will give a lot more surface area because every single piece of speck of powder, this contributes to adding more surface area into the metal. Compared to if we have a block of metal, the outside surfaces will be exposed to the acid before the inside of the metal gets exposed into the acid. So if you have powdered metal, that's going to give it more surface area, which is going to allow this reaction to produce more hydrogen gas and dissociate and dissolve a lot faster compared to this one. Okay, hope you guys got the concept of reactivity. If we have a chemical right here, let's say this cup full of a chemical. We don't know if this is an acid or a base. A litmus paper can be used. This is going to be a type of paper that's usually neutral in color. And once you dip this into the solution, let's say we dip this tip into the solution right over here, whatever touches the solution, if it's an acid, it's going to turn red. So if we grab our litmus paper, put it into the solution right over here, and our strip turned red right over here, that tells us that our solution is going to be acid. That is going to be the end of today's lesson. Today we talked about dissolution of acids, taste of acids, reactivity of acids, as well as how a litmus paper can be used. I got some more example problems for you for in the next video. If some of this seems confusing, go and check out the previous videos where we went ahead and talked about the introduction of acids and some example problems on how to identify acids. Hope this video helped. I'll see you guys in the next video.